Now that we have seen what upthrust is, we can sort of start to study, okay, why is it when you drop some objects into a fluid, it will sink, some of them will end up floating, or on the rare occasion, they may just stay in limbo somewhere in between. Now, whether something sinks, floats, or stays in limbo is really a matter of balancing two forces. At any one time, okay, assuming that the water is incredibly still, right, then we have the weight, the weight is acting downwards, and we have the upthrust, as we can see. And so it turns out that if you sink, it must be the case that the weight is greater than the upthrust. And of course, if you, let's not say float, but if you rise, okay, then the other thing must be true. The weight must be smaller than the upthrust. And if you're in limbo, basically floating around, then they are equal. Now, here's something that's quite interesting. If we break down the weight, we know that the weight is the density of the object times the volume of the object times g, and the upthrust, as we have seen, is the density of the fluid times the volume displaced, and assuming it's fully immersed, then v will be the volume of the object as well, times g. And so you can see that the only real difference between weight and upthrust is the density term, right? Weight comes from the density of the object, and upthrust comes from the density of the fluid. And so we can conclude that if you sink, the density of the object must be greater than the density of the fluid. And this is something that we can definitely relate to, right? Stuff that are incredibly dense, like metals, will definitely sink. On the other hand, of course, if the density of the object is less dense than the density of fluid, right, they will rise. And so if you put something like a ping pong ball inside, it will definitely rise towards the surface. And if it is in limbo, then the densities have to be equal. Well, not many things have the same density as a fluid, but one example that I can think of is that if you fill the water bottle with water fully and you dropped it into a swimming pool, it would kind of like drift around and not really go up or down too much. Okay, and so this is why objects rise or sink. Basically, the density is the deciding factor, but ultimately it is the deciding factor because it affects weight, the balance between weight and upthrust. Now, something quite interesting happens when you have an object that is going to float. Now, when an object floats, you realize that it's going to become what we call partially submerged, something like this. You will notice this all the time. And this happens, of course, for objects that are less dense than the fluid itself. And so we have seen that, of course, let's compare the weight and the upthrust. Okay, we know that weight is the density of the object times the volume of the object times g, and upthrust is the density of the fluid times the volume displaced times g. And so initially when you were fully submerged, right, it was of course the case, right, for objects where the density is less than the fluid, it's of course the case that the weight will be smaller and you rise. But when you reach the surface, what happens is that you become partially submerged. And so you notice that now the volume displaced is less than the volume of the object. And this should equal to how much less the density of the object is compared to the fluid, in an effort to try and balance these two things. And therefore, when an object floats, it must be partially submerged because you want to reduce the volume displaced so that you can try to balance the weight and the upthrust.